Welcome everyone. Today I will be presenting on the topic analysis of non-recursive algorithm. My name is Gauri Kulhani. This presentation will cover various aspects of non-recursive algorithms including their advantages, disadvantages and the real-world applications. Let's start with the introduction. To begin with, let's understand what non-recursive algorithms are. These are the algorithms that solve problems through iteration using loop like for or while, without the need of the algorithm to call itself. The significance of non-recursive algorithm lies in their efficiency. They typically use less memory and perform better compared to their recursive counterparts. Let's begin with today's agenda. Here's a quick overview of what we are going to cover today. The introduction, which we have covered in the previous slide, we are starting with the basics and then compare recursive and non-recursive algorithms. We will explore their advantages and disadvantages, look at some examples and discuss their practical uses. We will also visualize the concept through graphs and conclude with a summary. Recursive versus non-recursive algorithms. Let's compare recursive and non-recursive algorithms. Recursive algorithms are the functions that call themselves, which can lead to high memory usage due to stack space requirements. On the other hand, non-recursive algorithms avoid these self-calls and instead use loop to achieve the same result. A classic example is the calculation of a factorial, which can be done both recursively and non-recursively. The advantages of non-recursive algorithm. Non-recursive algorithms have several advantages. They are memory efficient because they don't risk stack overflow and reduce the overhead associated with function call. Time efficiency is another benefit, as a non-recursive algorithm often executes faster by eliminating the need for multiple function calls. Moreover, their straightforward control flow makes them more reliable. The disadvantages of non-recursive algorithm. However, non-recursive algorithm does have some drawbacks. They can be more complex to implement, especially for problems that are naturally recursive, such as tree traversals. This complexity can lead to code that is harder to read and maintain, especially when dealing with multiple nested loops. Additionally, non-recursive solutions may require additional data structures to manage the state, complicating the implementation further. So let's begin with the examples. Linear time complexity. In this example, we are using a non-recursive algorithm to find the maximum value in the array. The function findMax is implemented in the C and works by initializing maxval to the first element of the array. It then iterates through the array, comparing each element with the maxval. If a larger element is found, maxval is updated accordingly. After completing the loop, the function returns the maximum value found. This approach has a linear time complexity, denoted as order of n, because the function must examine each element in the array exactly once. This makes the algorithm efficient for finding the maximum value in the array, regardless of its size. So let's look at the second example, constant time complexity. In the second example, we demonstrate a non-recursive algorithm that retrieves the first element of an array. The function getFirstElement written in C simply returns the first element array of 0 of the array. This operation has a constant time complexity order of 1, which means it takes the same amount of time regardless of the array's size. It is an efficient and straightforward example of a task that can be accomplished with minimal computation, emphasizing the simplicity and speed of constant time operations. So let's begin with the uses. Efficiency and performance. Non-recursive algorithms are faster and avoid the overhead of recursive calls, making them ideal for performance and critical tasks. Second is resources constrained environments. They are memory efficient and reduce the risk of stack overflow, crucial in systems with limited resources. Third is the iterative problem solving. Non-recursive methods are well suited for iterative tasks, offering simple and reliable solutions. Next is the graph linear time complexity. Here we have a graph that illustrates linear time complexity. The graph shows a straight line indicating that the time taken increases proportionally with the number of elements. This visualization helps understand why the findmax function is efficient and scalable. In summary, non-recursive algorithms stand out for their efficiency and simplicity. They offer lower time and space complexity, making them more memory efficient. Their straightforward control makes them easier to understand, debug, and maintain. These algorithms are particularly valuable in performance, critical systems, and real-time applications. Visual tools like flowchart can effectively demonstrate efficiency, and the practicality makes them a preferred choice in the computational scenarios. Thank you for your attention. I hope this presentation has provided you with a clear understanding of non-recursive algorithm and their importance in computer science.